Hi, we're going to give you an overview of RiverNET, which is an AI for trout project from Envision Yellowstone. So what do we mean that RiverNET is an artificial intelligence effort? And especially if you run a recreational business such as fly fishing outfitter, why might you even care? So let's start with the financial markets and why they're all hot and heavy over this topic called AI or artificial intelligence. Often financial markets are an indicator of whether something is seriously emerging in the economy, so it's good to take a look there for a second. Here's a quote from Byron Wien of BlackRock, one of the more well-known money managers in the world. Every year he publishes a list of surprises for the coming year, or predictions, and this year's surprises, he included artificial intelligence and said this: "If it's true, it's pretty significant. Artificial intelligence gains visible momentum. Service sector jobs are automated, particularly clerks in legal and finance professions, as well as workers in fast food outlets and healthcare. Economists begin to question the unemployment data because the rate drops below 4%, while so many people still appear to be out of work and seeking government assistance." There's been a couple announcements even since then, those predictions. One was a big tech giant, LG, who made announcements at CES about robots that they're rolling out for the service sector. It's significant because the service sector employs about 50% of the global workforce. And by replacing certain portions of that workforce, you could have a significant impact on business and social life. So, here you see a couple photos of what's going on in the marketplace. We have all these infrastructure things like buses and roads and elevators and escalators, and they break. I took two photos from a conference I was at in Washington, D.C., and ironically, we were just about to go into this big conference center, thousands of people, and the escalator breaks down, and they call it predictive maintenance. Well, it wasn't predictive maintenance, but companies have rolled out and are working on solutions that predict when certain things like an elevator or an escalator would break down and dispatch a worker in advance. By doing that, they can reduce their actual service labor force because they're not sending people out just to check and see if something's broken. The other photo is a big bus that broke down. Obviously, if you could predict with a level of accuracy, let's say 80% chance that the engine was going to malfunction, you wouldn't have sent the bus out of the depot, and you would have saved a lot of effort and work just to get it back. And also, obviously, a lot of customer satisfaction was impacted. But it's not just, AI isn't just impacting the commercial and private sectors. It's actually being used in agencies, government agencies, and even in environmental use cases. Here's an article in Nature about the case for using technology in the environment, and they gave an example. This was actually Microsoft. They have a program called AI for Earth that they're investing $50 million into, and this was a study on how to use AI to better manage salmon populations and their return to streams and rivers in the Pacific Northwest. So you can see AI. The reason a lot of economists are calling AI like electricity was at the turn of the previous century is it impacts all sorts of industries, not just private sector, but public sector as well. So, what is this buzzword artificial intelligence? Like all text buzzwords, it's a slippery one to define. But at its core, if you boiled it down to what it's really trying to do, it's all about increasing the accuracy of our predictions of the future. It's about probability. So here you see, the most famous prediction system that humans, have tried to invent, and that's weather forecasting. Did you know that weather forecasts for 3 days out are as accurate today as they were for just 1 day out 10 years ago? So we're increasing our levels of accuracy in our predictions for weather forecasting as we advance with artificial intelligence. What if we took that analogy and we said, we're trying to predict or increase the accuracy of our predictions about how good fishing will be in the next 10 days? Well, that's what RiverNet is partially about. We're going to make various types of prediction systems available to our users. And the holy grail for holy grail for fly fishing would be a prediction of, when is it good to fish? That's the question we as guides get all the time from our customers, whether it's the beginning of the season or they just showed up and, how good's the fishing going to be? It's an extremely difficult problem to solve, and it's one of our goals. I'm not going to give you a science primer on AI today. I'll save that for later. But I understand if you're a little bit skeptical that we can actually do that sort of prediction. If you'd like to sit down and hear my arguments as to why we think we can do that over a beer at Chico Bar near my home in Montana. But for now, I just ask you to take a page from the book Moneyball, which became a movie starring Brad Pitt, and Brad Pitt played Billy Beane. Hopefully a lot of you have seen the movie. He was the general manager of one of the worst and least funded teams in baseball in the 90s, the A's. The Oakland A's. He turned that team around by adopting statistical analyses, even though he knew nothing about it. And I quote him, "I'll never pretend to be a math whiz. I just understand its powers." So I'm asking you to set aside your skepticism for a little bit and hear what we're trying to do. And then we'll talk a little bit in a separate session about why we think AI will work. So again, I'm not asking you to become a calculus PhD here. I'm just asking you to believe in the power of more data to increase the accuracy of our predictions, not just to make you a more successful fly fisher, but much more importantly, to help us manage our watersheds to become more resilient ecosystems. Why is that important? Well, the stakes are high. Many of you around the upper Yellowstone River from Montana remember what happened on August 19th of 2016. All of the major news stations picked this up, including the New York Times, where they talked about this tiny invader resulting in the shutdown of the iconic Yellowstone River. In August of 2016, a large kill of native salmonids we call the mountain whitefish and some trout had an unusual die-off. The cause? To the best of our knowledge right now, it's an evolutionary sibling of an ancient jellyfish called, and I will destroy this, Tetracapsuloidus brysosalmoni. That was awful, wasn't it? They can bore their way through the skin of a fish and occupy and populate its host like an alien predator, resulting in what we call PKD, or proliferative kidney disease, and death. But TB, as I like to call it, isn't new to Montana rivers. And I've seen no evidence in the literature that we know why exactly these fish died this year in this area of the river. Multiple factors had to be coming together. Was it water temp? Was it base flow height? Was it pH chemicals? We don't know, because honestly, we don't monitor enough to make those conclusions. Here's a chart of the USGS water station near Corwin Springs in the upper Yellowstone River from 2016 and 2017. In these graphs, you can see discharge, conductance, and temperature. Let's just focus on discharge and conductance. So if we look at the readings for August 19th of 2016, we'll see that discharge was 1560 CFS. In 2017, it was 32. So you could argue, hey, it was a really dry season that year. The river was low, and fish, that was one of the contributing factors to this disease, this miniature jellyfish, resulting in a big die-off. But you see, the temperature variance in Celsius wasn't very significant. But the real point I'm getting at here is what if we go back to 2015, where we also know we had a dry year, and we pull up that chart. Here's what we'll see. You notice a difference? We don't have the other sensor data. We have discharge, and yeah, we could go pull some manual data that FWP has and others have. But my point is this. Peter Drucker, a famous business person, said, if you can't measure it, you can't manage it. And he also said it another way. If you can't measure it, you can't improve it. One of our biggest problems is lacking the data needed to make decisions about how to manage our watershed. And so in this entire presentation and the premise of Envision Yellowstone is that while we might be a nation in God we trust, we expect all others to bring data. That was a famous quote by Edward Deming, who was an American statistician, and we think if we're going to have debates over public policy about how to manage our public lands and our watersheds and our wilderness areas, we have to have the data, and we're sorely lacking in that. So here's our big idea. Envision Yellowstone's mission is to enable the outdoor industry, individual nature lovers, and public lands agencies with high-density, real-time data and artificial intelligence on natural ecosystems. We call it the Internet of Nature's Things. And we're doing this with an efficient economic model where science projects from the public sector and technology products from the private sector collide to innovate and solve the need for affordable monitoring of ecosystems so we can collectively manage their resilience. We fund the startup or capital costs to get these sensors in place with traditional charitable gifts and grants, but we fund the ongoing maintenance of those sensors and the support costs of those sensors with subscription-based products. So think of it as an NGO or a nonprofit with a technology spin that's going to raise money by allowing products to be subsidized for their ongoing support. A crowdsourced sort of model, except for on the front end. What are some of our projects? Well, our current projects from Envision Yellowstone are fourfold: AI for trout, RiverNET, AI for ungulates, AI for forests, and AI for species. We're here to talk about RiverNET. RiverNET provides fly fishing outfitters with access to real-time monitoring and alerting data, as well as scientific opinions on their local watershed. Our artificial intelligence tools enable outfitters to increase the accuracy of their predictions on things such as fishing activity, water flow, and population increases and decreases. By coupling our computer models with their local expertise, outfitters become more relevant to their customers. So what is it? What are the core features and pricing of RiverNET? At its bare bones, there's a mobile app that gives you data around this area in Montana that includes USGS monitoring sites, fishing access maps, local regulations, and whatnot. It's a cheap $5 an app download that you give to your customers to inform them about your local watershed. Where we're really focused, though, are on these second and third categories: the trout lovers and the trout experts, the outfitters. For the trout lovers, at roughly about $120 a year subscription, you'll get real-time data to our web portal, and this is where we have the high-density real-time sensors and information on 20+ parameters. You also can set it up to get text alerts to your phone or emails saying, hey, this threshold went above this or below that, so that you don't have to keep going back to some public portal to check on what the CFS flow was in a particular region. And then for our outfitters, this is where our predictive analytics and our machine learning models and AI algorithms are being used for a web portal that give access to predictive models. So tell me what you think the water clarity will be 10 days from now, those sorts of algorithms. It also gives you access to our scientific advisory board, and we'll be posting scientific opinions on things like what caused the whitefish to die. Government agencies and others are really risk adverse for obvious reasons, rightfully so. And so they're not willing to go out and say, this is what we really think happened. We're going to do that, right? We're not going to take the liability on it, but we're going to let our scientists actually speak to you, and you're going to indemnify them, but you're going to actually get the behind the scenes conversation from an expert in a particular fisheries biology sector. What are these predictive models? Well, I mentioned them briefly. I'll go into a little more detail here in our release dates. So in 2019 is where we'll roll out our first fishing activity predictive model. And this is a traditional supervised learning neural network. And we're using multiple indicators to model our predictions of fishing activity. And you can think of it as a simple KPI for a 10-day forecast. On this day, is fishing going to be, really, really slow, really good, or just average? That's what we're giving you based on these KPIs. And what's really important, you get to help make the model even better. So you'll be out floating the river with guests, and you'll notice that fishing activity is awesome. Whether you're seeing it on the surface or underneath the surface, or you're actually experiencing it because you're catching a lot of fish, you will flag that area, and so we'll know your geocode. And then we'll have all of our sensor data, and we'll be able to do some more correlations in our model and make it better for its future predictions. The other 3 predictive models that we'll be rolling out in 2018 are water flow, fish population, and turbidity. Those are common needs that outfitters and fly fishers have. What do we think the water flow will be in the next 3 days? And what do we think it'll be this year in June? Based on snowpack and other climate models that we're using. Another one's the fish population. Hunters use this all the time. Is the elk population gone up, or is it going down this year? We'll be giving you that data as well. And then turbidity, it's a common one, especially on the Yellowstone River. What's the likelihood that we won't be able to fish the river in the next 3 days from today because it's going to be muddy? And that way I can maybe replan for my guests to go fish one of the private lakes. So phase 1 sites on the upper Yellowstone. This is just for the upper Yellowstone. Each one of these markers on the upper Yellowstone watershed is a sensor kit that we're putting out. Some will be on the Yellowstone, some will be on some of its significant tributaries. And that's what we're rolling out this year. All of that collective data goes into running the models and doing the predictions, and that data will be available on the public portal. The timelines, RiverNET is just wrapping up its business and marketing plan. We've already secured some funding. We'll be closing our final round of funding by May 1st. Our upper Yellowstone sensor build out will happen starting May 1st through August. We'll be releasing data as they roll out, with plan to have the first set of data going live in early May, right before runoff. We might have to do it sooner based on snowmelt this year. And then our grand opening, or our portal launch, is on August 19th in commemoration of the 2-year anniversary of the river closure. Our goal for this year is to achieve 10 outfitter customers and 500 mobile app customers. Those mobile app customers are actually will be clients of those outfitters. Who's the RiverNET team? Well, there's many of us behind the scenes, but the core team is myself, the founder, and you could consider me as the person trying to guide and juggle all the balls in the air for doing an initiative like this. We have our chief research scientist and smart guy in the room, Bob Crabtree, one of the experts in the Yellowstone ecosystem, and a great scientific modeler on multiple levels. And then Katie Gibson, our CTO and code guru. And then we've got an advisory board advising each one of us. Pat Byrath from Trout Unlimited, making sure that we're meeting the needs of the end customer, the outfitters and the fly fishers. Pat LaPointe, who is a great mentor in the business world and the NGO world. How do we do this in a sustainable way? How do people pay for this such that we don't have to go secure funding every year? And then Ashish Parikh, who runs the IoT platform for Aero Electronics, as an expert in sensor systems. We have a Science and Conservation Board. These are some of the people that we have on our team, and these are those experts that you'll have access to as an outfitter or a customer, and giving opinions about what we think happened, and more importantly, creating the models, the predictive models that you'll be using. Some of our partners on the top are technology partners. In the middle are some of the state agencies and public agencies that we partner with, and NGOs that have a lot of expertise in ecosystem management, ecology, and whatnot. So we're filling a need for them, and they're filling an area of expertise for us. And then on the bottom, some of our partners in the let's call it the fly fishing world. So we've got companies like Sims out of Bozeman, and Sage is putting Sage Lodge in Paradise Valley this year and going live this summer. And we've got great organizations like Trout Unlimited and Fly Fishers International here locally that we're partnering with, again, to make sure that we're servicing the customer's needs. Phase 1 required funding. We've already raised $100,000 for the IoT web portal that goes live this year, and the remainder of funding we're closing. And this is just the upfront capital funding to get all the sensors launched. So we're using about $25,000 of compute and hosting time to run the models and get the predictions to where we want them. About $50,000 in hardware for the 10 sensor kits. Our deployment labor is about $50,000, and the labor to create the models about $50,000. So that's our budget for this summer. And beyond that, our business model is done in such a way that the maintenance of these systems can continue to operate year after year after year, and we don't have to go seek more funding. Again, Upper Yellowstone is just the first place we're deploying this, and the plan is to scale this out to other places nationally. So that's an overview of RiverNET and one of the things we're up to at Envision Yellowstone. We hope you're as excited as we are. This isn't just about, getting predictions about when fishing is going to be good. This is about knowing more about the ecosystems of our great public and western lands and how we can better manage them for future generations. So we hope you're excited. We hope you want to participate and be involved in whatever way you want to. And you've got my contact information here and my cell phone to reach out. For those of you who want to stay on, I'm going to transition now and give a brief AI primer, like I mentioned earlier on. For those of you who already know that stuff, you can just hit delete and end the presentation. Have a great day. So artificial intelligence and data science in general is core to the mission statement of Envision Yellowstone. And while many of our research scientists and some of our tech partners understand what AI is, what machine learning is, and data science is, a lot of our customers don't. It's kind of a magic box. And some of our customers are NGOs, some of them are agencies, some of them are actual outdoor recreational companies. And this whole buzzword that's going around about artificial intelligence and robots taking over the world, a lot of it gets wrapped up in a bunch of hype that makes it difficult for them to see what it means for them. So we thought it'd be good to give an AI primer. Trust me, people do PhDs on subtopics that I'm going to briefly cover here. So don't expect this to be definitive. There's plenty of good videos on the web, and you'll see that I borrowed some ideas from some of them. This is really to show you why AI is so fundamental to Envision Yellowstone's mission statement. So let me give you a brief history of data science. This slide alone would take, 2 days to go through. And obviously I'm not going to cover this entire slide. It'd put you to sleep. But we thought it was important to tee up, our discussion of AI with this takeaway. The terms and the buzzwords data science, analytics, big data, AI, ML, or whatever the latest buzzword you might be hearing, it's not new. It's emerged over a century from various scientific fields of discipline, such as computer science, mathematics, statistics. It's crazy complex to boil down to one word, but they all share one common goal, and that's to increase the accuracy of predictions. It's not to be 100% accurate, because that's not what probability is about. It's to increase the accuracy of our predictions. So if we're 75% accurate, it would be nice to move that to 80%, right? It can have an impact on business, decision making, and all sorts of things. So we'll come back to that premise. So here's a framework to help you take all of that, that previous slide and say, boil it down for me, Jeff. Boil this complex topic of data science down. So this is one way to do it. If you think of AI as trying to create a thinking machine, that's what's hot right now. It's artificial intelligence and machine learning. And machine learning is really a subset of AI. It's often referred to as deep learning or multi-layer neural networks. The goal of AI is to create thinking machines. It's, at the heart of robotics. It's to integrate perception, prediction, reasoning, and decision making. In a nutshell, you could say that it's trying to mimic and in some case replace humans. Why? Well, it might be to increase customer satisfaction via predictable automation. Have we accomplished it? No, not even. But this is what college grads are getting paid 6 figures for. Some professors are making 7 figures to sit on boards, and economists are likening AI to what oil or electricity was at the turn of the last century. So if AI is this holistic body, or kind of the robot, the machine, with sensors and motor control, machine learning or deep learning is all about the brain of that machine. There are many kinds of machine learning algorithms, but most of them stem from what is called multi-layer neural networks, which really started to be used at a commercial level in the late 80s for things like character recognition that was used to automate check reading in check reading machines. Remember, before you had to take a check in and some human had to look at it, and now you don't have to do that at all? Well, that was due to that technology being invented in the 80s to do character recognition. And all the machines were trying to do is predict what someone had written down as a number on a check. So is that a 0? Is it a 1? Is it a 4? And having tried to read other people's writing, how difficult a problem that could be. It's really easy for humans, but getting a computer to do that was an extremely difficult problem at the time. Now we're using AI and machine learning for things like image recognition, right? You're seeing it in autonomous cars being built everywhere. It's being used in medical industries to predict whether someone has cancer. And it's being used in language translation. All of these things like Alexa and Google and Siri, all of that technology came out of machine learning. The high-level takeaway here is that deep learning is modeled after how the brain's neurons work and involves using a multi-layer neural network algorithm to help silicon or computers think at a basic level, but much faster and at larger scales than humans can. So rather than teaching a computer to, for example, tell us what objects are in an image by creating a bunch of if then then that rules, we train computers with neural networks to recognize objects, and we do it by giving them a bunch of examples, right? So we're not giving them rules, we're giving them examples. And when I say a bunch, I mean a lot. So if that's an overview of AI and machine learning with deep learning or machine learning being the brain, where does that leave all of the traditional analytics that came about before the 80s, right? All the way back into last century. Well, analytics came before AI, and it's been around for a long time, and you can kind of break it down into various categories like probability statistics, programming, SQL, visualization, UIs, big data. Those are the sorts of things that scientists have been doing before the 80s and 90s and are very helpful in creating models that are used to do various types of progression. Those of you who took college probability or stats remember regression analysis, right? Anybody who does a SQL computer or query in programming is creating reports and condensing down information so that it can be used to make decisions, in many cases predictions. The cooler stuff like fancy infographics and visualizations are trying to make massive amounts of data usable and understandable by end users. And lastly, big data, which you might have heard about, buzzwords, was a key transition point in traditional analytics, making a jump to AI. Big data focused on the storage and retrieval of very massive data sets. You hear about things, all this digital data that's being created daily, whether it's your camera, phone camera now creating images all the time, or it could be sensors that are in airplanes that are creating, terabytes of data per flight. Just massive and massive amounts of data. Well, storing all of that data in a way that could be retrieved was what big data was all about. All of these things led to kind of this emergence of AI and machine learning coming out in the 80s and 90s and making it possible to do this stuff. So in sum, analytics has a lot of overlap with AI, and each field is informing one another. But last but not least, what's the future hold? Well, there will be new buzzwords in the future, but I can pretty much promise you that it's going to come out of, be informed by, interact with current algorithms that are invented in the AI space and the machine learning space. So I showed you the really long-term history of of data science going back to the last century. Like I mentioned, the history of deep learning and machine learning is more recent, especially starting in the 80s with a tool called convolutional neural nets that were used to read handwritten digits and automate check reading machines. Apparently 10% of tellers jobs were eliminated in that time frame due to these machines that could do image recognition of characters. And then we moved into deep neural nets and this thing called ImageNet challenge, which reduced the error rate of predicting what was in an image by 36%. And now you have image recognition going into cars where they're being able to drive for you. Microsoft in 2015 created an accuracy of 96% on that ImageNet challenge, reaching the first time human level performance of object recognition was achieved. In 2016, you probably heard about Google's DeepMind or their AlphaGo, which is one of the most complex games humans have ever invented, Go. It defeated the global champion in the game of Go in 2016. No one thought that could ever be done. And then now companies large and small are launching deep learning products and services right and left in 2017. So you can see this rapid progression and advance of the technology just in the last decade. So why is there so much activity and acceleration in the importance of AI recently? When people ask me that, like, why wasn't it around here, 30 years ago? It's not just about the algorithms being invented and the theories of multi-layer neural networks, but there's a couple other factors involved, and this is the easy back of the napkin sketch. that might help you understand it. So on the y-axis, what's the goal of analytics? Well, it's to increase the accuracy of our predictions. Whether it's incremental or massive improvements, if a CFO gets a 10% increase in the 12-month cash flow forecast, it is a meaningful prediction to their bottom line. So that's the goal that we're trying to achieve. So if we plot on a graph on the y-axis that goal, and on the x-axis increasing amounts of data, and on the z-axis increasing amounts of compute, and then we show what happens if we use traditional analytic skills in this environment. What do we? That traditional analytics can't leverage as much as neural nets can, increasing amounts of data and increasing amounts of compute. Cloud computing has given scientists and researchers and developers access to massive amounts of compute, but you pay for what you use. You don't have to go build and buy this massive supercomputer just to do a predictive model to see when fishing is going to be good, right? The economics don't work. But now we can just pay to use the compute for our model, and then the business model might pan out. In addition, big data and advances in storage technology have driven the costs of actually storing massive amounts of data down. So with that increasing amount of data, increasing amount of compute, what you see is neural networks give you a lot more increase in the accuracy of predictions than traditional analytics has ever been able to accomplish. So with that, obviously we're playing catch up, and every industry is trying to figure out, how do I use this massive compute and data and neural networks to change the predictions I use for my particular industry. You know how much data it took to train natural language algorithms for Google, Alexa, and Siri? It took 5 years of continuous audio from over 1 million people to do that. That's a massive amount of data and a massive amount of compute. And it wasn't until recently that we could do that. So big tech companies are in a war to acquire this data. They want to own the large data sets. They've been buying up startups. They've aggregated large data sets. They give products away for free just to get the data. Why? Well, because machine learning gets more accurate on larger and diverse data sets. Accuracy makes your product better. You get more customers, and before you know it, you get this vicious positive feedback loop that helps make your business become more defensible. So if you leave with anything from this presentation, it's that data is the new oil, but neural networks is the fracking mechanism. It's the new technology used to get that oil and the insights on that oil out of the ground. So what can you do with data science if you're thinking from a business perspective? So traditionally, data science has been used repeatedly to do descriptive analytics. It's knowing what you already know, but presenting it in a way that's more informative. It's getting hindsight, right? What happened? Why did it happen? Doing some simple correlations, creating reports, summary reports. What was my sales by quarter last year? All of us, small business, big business, use descriptive analytics to understand what's going on in our businesses or our jobs. Predictive analytics is the next step up. It's knowing what we don't know. It's creating insights. What will happen? It's creating predictions. That's a lot about neural networks and machine learning is about. And then lastly, prescriptive analytics. It's not knowing what you don't know, right? It's using this technology to learn things that you didn't know, and you didn't even know that you didn't know it. So what should happen? Recommendations. You see that when you go on Amazon and buy something. It's getting foresight into the data that you have and what you're going to do with it. So let me give you an example of this in the real world, and we call it object recognition. I like to call it object prediction. It's solving that problem of what is in the image. I talked to you about that when it was first invented in the 80s to look at character recognition. What did someone write? Well, it's gotten so advanced now, and let me just play this little video recording of me showing some online tools where you can go do object detection just on the web.
All of the major cloud platforms have released AI as a service capabilities for developers to use to build their own products. Google and Microsoft, for example, you can go online right now and upload images and have them predict what objects are in those images. We often call it object recognition, and it's being used all throughout different industries, especially in healthcare, being used to do things like cancer detection, as good as the best doctors in the world. So here's an example. If I go into my computer and grab a file, let's take something like this and have it analyze it. I'll do the same on Microsoft's site. So everybody's competing to see how good their predictive algorithms can get. And Google's analyzed that image, and it's done some things like detect a face. It's predicted things like, oh, he's wearing a hat, right? Very likely wearing a hat. These are confidence levels. Remember, this is all about probability. It gives various objects in the image labels. So you notice it identified a trout, gave that an 81% accuracy, and went down through its predictive algorithms to identify what's in the photo. It can use data from the web as well and categorize different things in the actual image. Like here, it's identifying an object that's a bush. If I look at what Microsoft does, it's very similar things. It's tagging and giving confidence levels to different objects that it sees in the image. They're getting so good with facial recognition, they'll even predict gender. And here's a much younger photo of me and an age in it. So these are just simple examples of massive compute being used in cloud platforms to do predictive analytics and artificial intelligence to do image recognition.
So that's just online demo. You can go online. I highlighted the URLs there and try it yourself, right? You'll see that it's varying levels of accuracy. I took an image over here on the right side of the screen and ran it through both algorithms, and one thought I was holding a banana. The other knew it was a trout. Right? So it's trying to increase the accuracy of predictions. If you compare what this would have done 20 years ago, a banana was a big improvement. But as you can see, there's this feedback loop. If I tell it that's not a banana, that's a trout, the entire system gets smarter. It learns, and then it uses that next time. And that's what we're doing with our partners in Envision Yellowstone. We create the predictive models, we have the sensor data, and they can inform our platform by saying, you know, all of this sensor data you have on this particular day, I noticed that the fishing was good. Well, that just trained our machine learning algorithm, that all of this sensory data has a better likelihood of equating to a better fishing day. And you get this feedback loop until the accuracy gets to the maximum it can with the algorithm.
All the
So I'm going to close with this. I've been in the tech industry for 32 years now, and I can't tell you how much artificial intelligence is actually transforming what I refer to as the transistor industry. Deep learning, or machine learning, is the fastest growing workload in data centers, cloud data centers, public and private cloud. And obviously, it needs a lot of data and a lot of compute, but we're getting increased accuracy in predictions, and that's extremely valuable to businesses. So it's the #1 fastest growing workload in data centers. A company like Nvidia, who was making graphics cards primarily for gaming, right? When they started, they almost have a monopoly on the market of AI chips. And they'll generate about $9 billion of revenue in chips designed to improve artificial intelligence workloads. And that's not where they came from. They came from the gaming industry. You can see here in the middle all the different companies that are chip companies. Some of them new, some of them old, some of them former software companies like Google, who are getting into making chips that are similar to how the human brain functions and being used in AI sort of use cases. In the cloud space, every major cloud provider came out with AI as a service in 2017. And then you're seeing it change actual industries. Deere acquired a small, roughly 10-person AI company that was focused on increasing the accuracy of predictions to determine when a particular crop needed to be harvested. And you can see this John Deere machine here where these cameras are mounted on this cutting machine used for cutting lettuce heads, and it goes down the rows of perfectly aligned lettuce heads, and it's looking at the heads and determining, should I cut it off? Should I let it go? Cut it off, let it go. Cut it off, let it go. And predicting what the best time is to harvest. That was a small 10-person company of students who came out of Stanford, one of the top AI research institutions. And when they were doing their graduate work, they were going out with cell phones, taking photos of lettuce heads as they grew, working with the farmers to say, what's the best time to harvest this, and then creating their algorithms. And John Deere realized these guys have something. They go spend $300 million on a company that's not making any money, but they know it's changing their industry. So I just want to give you a sense for how transformative it is going on right now. And we're very lucky in the conservation industry to have this technology and use it to better inform, what we would consider a not-for-profit sort of model to, benefit our protection of our natural resources. So with that, again, I'll thank you for listening in, and hopefully this was helpful. Obviously, call me, email me. I'm sure some of you really bright people have some recommended changes or other ideas to add to this, and the goal is really to help the non-technical community understand the benefits of AI for their particular industry. So with that, I'll close and have a great day.